Hey, how are you doing, guys? I'm Toby. During this 2 year study in Okanagan College, I've learned a lot about how to repair and refinish a vehicle. And today, I'm gonna share some of my knowledge, which is also my topic of my final assignment, welding aluminum. From my experiences, welding aluminum is way harder than welding on steel. Before we start to do a proper welding on aluminum, there are also few things that important to know that why it is difficult and how to welding properly on aluminum. In the first, we need to understand the characteristics of aluminum. As we know, there are a lot of difference between aluminum and steel. First one, aluminum has much lower melting point than steel. The melting point of aluminum is 1200 Fahrenheit, but steel has 2500 Fahrenheit. Not only that, aluminum has faster heat transfer than steel, also a greater thermal expansion rate, and also when you heat it aluminum, there are no color change on aluminum. When so you cannot tell if there are too much heat by color. That's why it's easy to get burned through. Second thing is aluminum oxide. We need to understand what is aluminum oxide. When aluminum contact with oxygen, it will form a very thin layer of film on the surface of aluminum. It is also self-healing. When you try to remove the coating, it will come back shortly. Aluminum oxide could protect aluminum from corrosion, but also can trap moisture and dirt. Melting point of aluminum oxide is also higher than aluminum. It is 3725 Fahrenheit. Thus we have to remove aluminum oxide before welding. Otherwise, it will cause porosity or not enough penetration. Then we're gonna talk about preparation before welding. First of all, PPE is the most important thing we need to protect yourself. We need a welding helmet and a leather heat resistant gloves. Other than that, we need to have a proper equipment for welding. Stainless steel brush to remove coating. It should be stainless steel, not mild steel. Once the brush used for aluminum, basically it stays with aluminum forever. And MIG welder with 100% argon shielding gas. Also some vice grips to clamp your welding pieces. After we have all the equipment ready, then we are going to set up our welder. We are gonna use MIG welder to weld aluminum. MIG stands for metal inert gas, which is 100% argon. We are gonna set up our shielding gas flow rate first. We should set it up to 25 to 50 cubic feet per hour, but it also depends on transfer method, aluminum thickness, and nozzle size. Different materials should adjust to different data. Then we are going to set up the amperage and voltage. It is depend on material thickness, joint type, means how you gonna weld it, lap joint or butt joint. Also your electrode diameter, which is the feeding wire. Normally, once you type in the material thickness, it will automatically set up the amperage and voltage for you. But you can also adjust it by yourself later. If not, there are also a table inside the welder that include all the data we need. We can put it in manually. Then we are gonna inspect our welder. It's important to do. We need to assure that gas tank is not leaking, proper wire, proper setting, and there are no bird nesting, and your contact tips should be clean. After that, we're gonna prepare the surface. Any coating and oxide must be removed before welding. That's the first and also the most important step before welding. We can brush it off or we can sand it on. Second step is clean the surface by wax and grease remover, which is 203 that we used in school. Also, aluminum cannot use weld-through primer. After all the preparation, now we can start to weld. First that we need to know is we need to use push technique. Welding gun is pointed and pushed away from welding pieces. It will direct shielding gas to the front and make good shape. It provides us a clean action. We need to push straight, never whip the gun back and forth, and do not use pull technique. Pull is for steel, not aluminum. Gun angle. Gun angle should be 5 to 15 degrees from vertical, not 45. 45 degree is the work angle for lap joint. We need to remember the difference between gun angle and work angle. Work angle always varies by joint design. As I just said, lap joint should be 45 degree if the materials are the same thickness. If not, direct more on sticker panel. Butt joint should be 90 degree. Also, stick out distance is about 10 to 16 mm. It will affect arc length. Also help to control beam height. When we welding, the travel speed will decide how good the penetration is. Different setting, different travel speed. It varies by transfer method and wire speed. If our setting is high but travel is slow, it will cause burn through easily. Tail in. When we welding, we should start weld off joint. Move in after the arc is established. It could avoid cold start. Craters. We want to avoid craters happen. We could restrict arcs in the end, because it's a weak point of the weld. After welding, we should do a proper inspection by visually first. A good weld should have a penetration evident on the backside. Beam dimension is good and stable. Craters are filled. We could also do a destructive test, means try to break the piece that you just weld. Is the piece break from the center that where you just weld? It's not a good weld. After all the technique, there are also a few tips for welding aluminum. First one, there are 3 transfer methods recommended for aluminum: pulse spray arc, and short circuit. For me, personally, I think pulse spray arc is the best transfer method for aluminum. Due to my experience, here is a video explain what is pulse spray arc transfer method.
Pulse spray transfer sprays a stream of tiny molten droplets across the arc from the electrode to the base metal. But unlike spray transfer, the stream is not continuous. The power source rapidly pulses the welding output between high peak currents that cause the transfer to spray and a lower background current that maintains the arc but does not allow any metal transfer to occur. The pulsing of the current produces a buzzing sound.
Okay. Second one is body position. We need to practice various body position and trying to find the best, most comfortable one for ourselves. We must be able to see the weld. Also, we can support welding gun by another hand to make it stable. Third one is wire speed. Wire speed is the same as current. So if we increase the amperage, means increased wire speed, increase heat, and vice versa. Also, we should timely our welding. Weld as soon as possible after we remove coating, because aluminum oxide begin to reform instantly. Other than that, I want to mention some common mistake happen in welding. Suckback. It means too much heat. We could reduce setting and increase travel speed slightly. Porosity. It happens always because no shielding gas or something is contaminated. Maybe shielding gas, electrode wire, or the welding piece didn't clean properly. Last thing is cracking. It always caused by overheating. We could reduce heat to solve this problem. Okay, that's all of my presentation. Thank you all for watching.